This episode of Gateway FM podcast explores which recent technological advancements just took the cost of development, deployment, and support of Web3 and blockchain projects significantly down, and what brings the whole technology closer to inflection point from where the adoption, in my opinion, should start more or less on the tangential function trajectory. But Peter will give us a little bit more detail. Let's listen to this. Hi, Peter. Thanks for joining us.
Hello, Dennis. A pleasure. Yeah, it took some time to get me on board, but now I'm here, so let's get this started.
I'm very, very grateful because there is so much to talk about. Web3 infrastructure becoming more and more affordable, and there will be so many real-world applications. There will be so many applications within Web3. Let's just start talking about this. Whatever is on top of your mind, tell me, and then I will have quite a few questions to unfold this. What's going on? What's happening? Why is it becoming cheaper, and why is it becoming better? Like, what are the advantages?
So yeah, I mean, we spent quite a long time now. It's going to be almost a year experimenting and developing different kind of technological tech stacks, and concretely with CDK, with Polygon CDK, right? In the past few months, what we've been doing is, firstly, obviously, you need to make the technology stable and reliable, right? So it works as intended. There is no downtime, that people can use it and projects can build on top of it, right? When you reach this point, I mean, when you are in the process of innovation, the cost is obviously rising. The focus is on making things reliable, right? Let's just put it at that, right? When you reach this inflection point and things work, right, then you can turn things around and start looking at, okay, how can we now optimize? How can we bring the cost down? How can we make this more affordable for projects to run, right? And this is where a lot of our focus has been over the past few months, bringing the cost of infrastructure, specifically on Polygon CDK, to the levels that everybody can quickly approach, access it, spin it up, test it out, and then work from there. So you have different options to upgrade. You have different functionality that you want to implement, but essentially it's the starting point. The starting point needs to be easy to access and maintain.
Can we say that we are actually at inflection point of Web3? Meaning, like, you know, how it happened for AWS, how it happened for internet, how it happened for like 4G, 5G, the level of adoption, it seems like it's going to explode soon. That's my impression, at least.
Definitely, I'd say that we are, at least, maybe we are not there yet, but we are getting closer and closer. And this is also what we see in the market. From my perspective, definitely, it's hard to say when the inflection points happens, where we are in this state right now, right? But in a few years, we'll look back, we'll be say, okay, this is the exact point where the inflection point was. I definitely agree that we are very much close if we haven't passed it already.
It's interesting because from the inception of blockchain, it's been 16 years or so. And that normally what it takes to get to inflection point of an average technology. Of course, you can argue, of course, you can calculate differently, but yeah, okay, I hear you. And so why you specifically focus on Polygon CDK? What's the key advantages there? There are so many different ways to go, but you're working within the Polygon. So what's going on?
Well, I mean, right now we have two options in the market, right? We have the optimistic approach to scaling, and we have the zero knowledge approach to scaling. We, as a company, and also personally myself, I do believe in zero knowledge because of the added security that it brings, right? And this is why Polygon, I would say, Polygon has been the first one that kind of introduced the technological stack for ZK rollups, right? We are seeing others now coming up as well. Linear recently open sourced their stack. Scroll is as well very close to coming out. We have Taiko as well. Starknet has its own solution that is a bit more, a bit, I don't know how to put it, but it's not EVM compatible, which has its trade-offs again. But with these things, I believe that ZK is the way forward, right? Obviously, as we started at the beginning of the podcast here, is like the trade-off is always there. With ZK, it means it's a bit more expensive, right? And this is where we started. So now, as I mentioned, we reached this point where you can focus on bringing the cost of the tech down. And what we did is an interesting thing. What we just discovered basically in the past few weeks is, right, that we can now bring the infrastructure cost at par with other optimistic, so Arbitrum and Optimism. But there is one difference, right? So it's the cost of the prover. Prover is the heavy machine, the strong piece of the infrastructure that is actually the expensive one. And this is what separates OP or optimistic rollups from ZK rollups. And this is where the difference in the costs comes from. So effectively, you're not paying more for ZK infrastructure, you're paying more or less the same, but you are paying for the security or proofs effectively.
Can we unfold Prover a little bit? What it is, what it does, why is it peculiar to ZK, and why does it cost so much?
So, I mean, I need to put it across, I'm not technical, right? So maybe I'm not the best person to go really deep into what Prover does, right? But the Prover is the crucial piece of infrastructure when it comes to providing the security, right? So what we have is layer 2, either it's Validium, it's a rollup, it rolls up the transactions on the layer and it passes them on as a single transaction to the settlement layer, whether that's L1 on Ethereum or something else, right? It doesn't really matter. When you have this, when you add the proof, right? The proof is, well, zero knowledge is the tech where you can prove something without actually exposing what it is, right? So when you post a batch of transactional data to L1, and in parallel, you also post the proof, comparing those two things will confirm that the state of what happened on the layer 2 is actually correct. And I do excuse myself because maybe there are some discrepancies and we don't want to go deep into that, but that's effectively the thing. So when it comes to optimistic approach, you just post the transactions, right? But there's no proof, right? So you have this challenge period where somebody can come and say, okay, this is something that is not true. Something happened, whether it's a fraudulent, malicious transaction or whatever. So you have this period that affects finality. So your transaction won't be final until the period where you can challenge the transaction passes, right? Now, we haven't really seen anyone submitting those fraud proofs, right? So you can always say, okay, somebody needs to monitor, there needs to be capital put as a bond when you want to challenge the transaction. So those are all things that make ZK, in my opinion, more future-proof, just because it's based on the cryptography, on the tech, rather than on some human interaction that needs to take place in order to confirm the validity of the state.
It sounds to me that optimistic rollups and zero-knowledge rollups, they just have different applications. They're both fantastic technologies, and we're both thankful for all of them happening because it really enhances the world around us. But for you, since you are focusing on ZK and like personally your mindset is in there, what are the applications of zero knowledge that are there, and what are your clientele as well? Like what types of projects are you working with?
Sure. So, I mean, as you mentioned, this is very much on point, right? The question when you are choosing the stack is what you want from the stack itself, right? Are you looking for security, or security is not so important, right? So let's take a look at some gaming application. Does it really matter to prove every single move that a player makes in the game, right? Not so much, right? And this is why OP or optimistic stack is good for that, because you are not really going to challenge, okay, this player took a turn on the right instead of on the left, right? But when it comes to financial applications, anything that processes significant value, right, you need this security to be there, right? And right now we have this option. You are choosing the infrastructure stack. As I said, the underlying infrastructure cost is the same. It's just a question, do you want the proof or you don't want the proof? Are you comfortable with dealing with the ambiguity or a bit of an uncertainty on the security side, or you really need it to be, as we call, foolproof solution that cannot be cheated in any way, right?
Okay, thanks. And why does the cost of ZK technology goes down now? And why was it higher before? What's going on, and what's happening with this advantage of technology?
So first step for us was to establish and stabilize the network, right? We introduced the new tech. We brought Erigon client to Polygon CDK, and we had a few months of testnets and mainnets running, which showed us what are the actual requirements, right? When you start with something new, you are making presumptions. When you're making presumptions, you have a tendency or a requirement to put more resources just to be sure, right? Okay, now we put these more resources, which obviously meant the thing is very expensive, right? And now we are looking at the usage, how the network is behaving. And then we see, okay, we don't need that much storage pre-allocated, for example. So we can take that away. The network will operate in a similar manner. The performers will still be there, right? But this storage won't be waiting for it to be used, because we can add the storage once we need it, right? You also like have servers are over provisioned, right, by default. So you want to make sure that everything works, and even in any edge case when you have increased peak loads, the network doesn't break, right? Now what we can do is we know what is required actually for network to be stable and where the network will operate, which means we can bring the costs down, put this as a baseline starting point. And when we see increased usage through monitoring, we can always add resources on demand once they are required, rather than keeping resources deployed just in case something happens, right? And this is how we are now going reverse engineering and going back to find the most stable basic setup where we start. And what happens later obviously depends on different factors, what requirements you have, and we can always upgrade and add resources on the go. But this will now remove the false perception of the fact that infrastructure for ZK rollup is expensive. It's not. I mean, it's the same thing as for any other rollup, right? As we said, it's only difference with the prover. We have a lot of advancements and R&D working on that side as well, developing shared provers, right? So you won't need your own prover dedicated at all times. Again, having your own prover means if you're not utilizing the whole thing, you are, again, over provisioning. But you can't share that with anyone else, right? So if you connect to a shared prover solution, you will just be consuming enough resources that you need at that single time. If your network load increases, you will get more resources for that period, right? And you will pay for those resources rather than paying for something that you might use, but you don't use for the majority of the time.
Okay, thanks. Let's talk a little bit about the real-world applications of this, because there is, of course, a whole bunch of different Web3 projects that you support that just happening within the field. But let's take a broader look. Since the technology becomes more and more affordable, what kind of industries should start looking into maybe building proofs of concept, maybe building some sort of draft projects or some sort of innovative solutions to like cutting edge technology? What would you recommend, or which fields do you see engage in these Web3, considering the cost cutting in the nearest future? Well, nearest future we'll have to define, right? It can be half a year, it could be a year, it could be a couple of months from now. We don't know when exactly it's going to happen, but what projects do you think can benefit from that? And we can take also a couple of examples, like on a broader level, but also in specific examples.
Sure. So, I mean, let's start with looking at two sides. We have two sides here, and I want to relate back to the point where you mentioned inflection point, right? So what defines for us an inflection point? Up until recently, or let's say in the past few years, we saw anybody who was building on or developing something or innovating new solutions on the blockchain, they came from within the space, right? So until we are working only from within the space, right, I don't consider that an inflection. But what we've seen is now traditional enterprises from the Web2 side, from anything like Microsoft, like big companies, they are starting to look and express interest in this technology. It's been battle tested. They've seen it work, right? Now they are thinking, how can we utilize this? Because there's obviously an advantage to utilizing this technology. Otherwise, we wouldn't come to this point where we are, right? So these are two different segments. We are talking about businesses, use cases that have existed and worked on Web2 infrastructure, let's call it like that. It doesn't matter, right? And then you have projects that are trying to build something from within Web3 space. This is actually the part where this cost cutting and bringing the technology, making more affordable, is more important than for the traditional enterprise, because those are startups. They have their own runways. Those things affect significantly how much they can spend on the infrastructure, right? So here we see a lot of application. I mean, it's gaming, it's this DP in decentralized physical infrastructure, whatever they call it, identity, DeFi, obviously, right? So we had DeFi developed throughout the whole history of Web3 space, right? As one of the major use cases of the technology, right? So these are all things that are now experimenting and seeing how the scaling technology and having their own rollups will contribute to them, right? But what am I personally interested in is what kind of use cases will be brought from the real world, let's call it the real world, and utilize the tech, right? This is where the inflection will actually happen. So where will we get the next billion users? It's not going to become from Web3 space. There's not a billion people in that space, right? But there is like 3-4 billion people connected to the internet. Those are the inflection point defining users, right? Let me stop at that. Maybe you have a follow-up, and we can talk more.
Yeah, I can just ask you to continue, because let's talk about these real world applications. What kind of projects can start benefiting from it? Because you mentioned that there are big companies and corporations, like there's Microsoft, Sony, IBM. They're all looking at, like Amazon. They're all looking into extending into blockchain technology, because obviously the benefit is there. We will talk separately about the benefit as well, like why go blockchain, why go Web3. But let's talk a little bit about the real world applications. So what kind of projects? Let's take a couple of examples. What can benefit from it? And since you are focused a little bit more on ZK, I know you're well versed across the field, but since your niche is in ZK, let's focus on this more sort of security demanding projects.
I mean, anything that processes, I mean, let's say it has been, the narrative has developed over the past 20 years that the data is new gold, right? So it doesn't even have to be funds or money or whatever. It can just be sensitive data that cannot be lost, that needs to be processed and stored in a certain manner, right? So what we've seen, again, let's take a comparison of the most obvious that everybody knows, like between decentralized DeFi, whatever we call it, the financial use case, right? So what is the difference between a DeFi infrastructure or the traditional infrastructure, right? It works 24/7. It doesn't stop. You have settlement non-stop. It doesn't stop over the weekends. It doesn't stop at 5 p.m. New York time, right? It just works, right? So you have this non-stop settlement ability that is not available because on the traditional side, right? Then what we see is also logistics supply chain, right? There's a lot of processing. The data needs to be stored in appropriate manner and accessible at any given time to the users that have access to it, right? So this is another use case that we've seen developing. There's obviously privacy. Privacy is a very important topic, especially for enterprise, because they don't want to give this data to be publicly accessible. And this brings us to a point of decentralization, right? We're talking, like, blockchain became a synonym of decentralization, right? But these rollups that we are looking now, they're not decentralized, right? It's not about decentralizing. It's about building and providing infrastructure for your specific use case. So if you want to decentralize it, if that's a part of your use case, sure, you can do that, right? But if you don't, that's also the option, right? So we give more and more variability and optionality to build these real world use cases on chain that previously weren't there, because you just had Ethereum L1, right? It was expensive, it's slow, it's all these things that don't facilitate the use case to be brought on chain. Worst case of all is this best case of the blockchain, right? So the data is accessible to anyone. You don't want that, like enterprise doesn't want that. And this is why you now have these options to spin up your own infrastructure, adapt it to whatever you need, and they'll build use case on top. And this is what we really need to focus on. Infrastructure is going to become a commodity. It's quite clear, right? But the use cases, so infrastructure is there, it needs to be cheap, it needs to be stable, and you need to be predictable what's going to happen to it, right? And then the use case that when you have all of this, when we take care of this base layer, then the project enterprises, they can focus on really bringing or building out a new use case on top of this infrastructure. The question is, what do you need, right? Where do your project will live? What do you want to do with it? And what are the underlying requirements where it needs to live? Let's say it needs to live. So what kind of home are you going to give to this project of yours, right?
Okay, interesting. And let's maybe unfold certain key performance metrics. Like, Web3 comes to the technological field, and it offers certain advantages. And you mentioned a whole bunch of them, right? This could be, which is also interesting. It could be also centralized. It can be decentralized. It could be, you could have a extra privacy. You could have extra scalability and all of this type of things. But how do we communicate this to a broader audience so they also hear this? What kind of metrics will it help them to achieve an increase in if they would adopt Web3 technology? Again, I think you mentioned like security, scalability, and maybe like uptime, as you said as well, and maybe there is some the throughput. Like what happens? Like what does Web3 in terms of these specific KPIs brings in?
Well, I mean, again, because it's a tough question to answer, right? Because you have all this optionality, and if you want to look at throughput, a Web2 network will give you more throughput than a Web3 network right now, right? So again, Vasil mentioned, I believe, in the podcast when he did, like, it's about the narrative, and here it has to be emphasized. Yes, it's a lot about the narrative. I wouldn't say we have a completely clear idea of what this will bring and what will it enable, but right now people are experimenting. We are still in experimentation phase, right? Optimism and Arbitrum has been out with their stack for quite a long time, about 2 years, I believe, and it's a battle tested, right? So we see more adoption on that end, and ZK is just coming up in the last year or so, which again will bring more and more adoption. But right now they need to experiment. They need to see what are the use cases that are getting from. But essentially it always brings us back to the fact that you are providing a place where your application, your use case, whatever you have, will live, right? And this is something that now you can own, and you own it, and you can do whatever you want with it. And then you can also make it, again, whatever you want. You can decentralize it. You can bring in stakeholders that will operate the nodes, that will validate your network, right? You can select it. You can make it completely open. You can make it completely centralized and run everything yourself, right? So this, again, it provides us with a broad spectrum of options, and we need to explore. And every company, every founder, they need to know and really think about what they are looking for, not just like it's popular, let's do this, right? But what this brings, these questions that you are asking, they are tough to answer, right? I do see that a lot of clients, they don't really yet know what is the benefit, right? But they know that they need to have something on their own. They need to have something where they can provide users with very cheap or affordable transactions, way to transact and utilize their protocols, right? So this is the main use case, is to enable, because you can make it, for example, gasless. So all the transactions that users will do, they won't cost anything, right? So it's, again, all this optionality that we are creating on top that was not available at the layer 1 as by default, as well as layer 2s that are public networks, and everybody needs to adhere to the same set of rules which were programmed into that layer, right? Here you can program your own set of rules. Obviously, you have something that is defined by the stack, some of these limitations and trade-offs, but I personally always see the technology, like if we would approach this and say, okay, it's not possible to do something, then we wouldn't be here right now. We wouldn't have internet, we wouldn't have blockchain, right? So there's always a possibility. You just need to explore, innovate, and then implement it, right? So I would say that optionality that this rollouts brings is a very interesting thing. And now optionality then gives you options to utilize whatever is most useful to you and let everything else for the rest, right?
And we will talk about this in the very end of the podcast, of course. But I will just mention that you can help people to understand whether they need a certain technology and what technology they might need. But let's talk a little bit about the other examples. Like I know that in ZK specifically, right, on that stack, payment system is something that is easy to build, and we have this issue now with banking, because banking is slow and it's very I don't even know what kind of word to choose, but it's moving extremely slow. The whole industry, whether it comes to interface, whether it comes to transactions, whether it comes to all the regulations and everything. That's why we see companies like Revolut who just come there and take over the market because they break the barriers. But we also know that the technology of Web3 helps to break the same barriers. Like, how can a bank, for instance, can adopt Web3 technology today? Is there any kind of, where do they start even? What's the first step, and how can they think about, maybe it's building a new bank, right? Maybe it's making a span of an existing one to a branch to try proof of concept and something like that. Where do you begin?
I mean, with banks and with the finance, it's about settlement, right? You send transaction from your bank account to someone else's bank account. It's just passing some digits, right? Some digital pieces of information, and they need to settle, right? So we need to have a ledger where it says, okay, now this amount left from this account and it came to that account, right? So we don't have duplication. And blockchain by default solves this by it's pre-coded, and this was the initial idea behind it, right? So you can send it from one end of the world to the other end of the world. We've seen, I mean, it's not something that banks are, I mean, banks, I guess they have their own interests, right? They want to keep things in a certain way, right? But then when you have an alternative shaping up, Revolut is an alternative, right? And but still, it's a digital bank, so they figured this out, yet they still use the same old infrastructure, right? We just heard this week the news coming out regarding Revolut starting to explore or even build their own stable coin, right? Why do they need their own stable coin, right? Because right now they are settling euros, USD, right? So they still need to connect to the same old infrastructure to be able to settle that, which has costs for them, obviously, right? And it has its limitations, right? So now they are enabling, if you want to send from Revolut to Revolut account, you can send it on Sunday night, right? Because they have their own ledger, right? But this is adding additional layer of complexity because then they need to settle that ledger into the global system, right? Here, it's one global system. Even if you have your own roll-up, it's going to get connected in some way to that one global settlement layer, right? And this is something that banks will at some point start to realize, but they have a whole bunch of their own problems that they don't want to give up, right? They have control. Right now, you have a bank account. If you don't behave nicely, well, they'll just block it, right? So when you have your own wallet, sure, nobody can block it. I mean, again, it's connected to the real world. That's now let's call it imaginary world in the cloud of Web3 universe. But if you want to buy something, it still has to be connected, except if your buyer is also willing to accept that thing. So this is why it's going to be hard to eliminate the whole. I mean, it's basically impossible because nevertheless you will always find buyers that are willing to accept. But still, you have this option where you can't bring your funds back to the real world because for that thing you need a bank, right? Banks, yeah, I don't know. I'm not a big fan of banks, to be honest, right? So let's see how they figure it out, what they want to adopt and what not. We've seen an interesting case when European Union was putting across a blueprint or kind of a plan for this CBDC, central bank digital currency, right? And then they already had their own ideas of how to pre-code the ability to control the funds, which defeats the whole purpose. Then just stick to the old system and let's move on, right? So yeah, banks, I mean, settlement is one thing, obviously, that we want to, that they would benefit greatly from. They also have single points of failures. I mean, they have high infrastructure requirements where they need to host their ledgers on different sides of things and so on and so on. So there are obviously things that can be useful and utilized, but for them, it's a matter of whether they have interest to do it right now. I don't think that they really do. They don't care much. At least from me talking to my friends over at investment banks and so on, they don't really bother too much just yet. But there will be, like, this is a different inflection point, right? When we reach that one, they will be kind of forced to adopt. this new technology, if we believe that this new technology will actually prevail.
And there could be some smart banks that will adopt this technology, will start adopting this technology earlier. And who knows, maybe that will give them the competitive edge, because it will be such a long time. We know big enterprise institutions, how difficult and long it is for them to turn around. It's like massive ships that takes time to pivot. But yeah, I understand that. That's an interesting perspective. But once you do get to adopt the technology, let's talk a little bit, go back to infrastructure. What kind of infrastructure is needed? I know that, again, what you're working with is basically complete Web3 infrastructure, and the people just need to bother about their project on top of it. That's fine. But let's unfold this. Like, what is within the block of the Web3 infrastructure? What needs to be there?
Yeah, I mean, it depends obviously on the stack you use. Like, this is basically the tech stack, either Polygon, CDK, Optimistic, and so on. It defines what kind of components you need, right? But you need a bunch of services, obviously, and let's not get deep into that. You need a sequencer. A sequencer is a machine that is going to put the transactions into sequences of transactions that then get transferred down to the next settlement layer. You need, again, this differs a lot from tech stack to tech stack. But if we look at, and this is like, it's hard to talk about this specifically because it's also changing, right? With optimizations that we did, we decreased the amount of components that are needed, right? But in ZK, when it comes to CDK, you need data availability. So you need to store data somewhere so it's accessible, and you need to confirm, right? So you need data availability nodes. You need the sequencer. You need the prover, which is that. And then you need RPC nodes as well. So RPC, so you can connect and communicate with the blockchain, right? This is in essence what you need. You will always need RPC, right? You will always need the sequencer. This is unified across. Prover is obviously for generating ZK proofs, so it doesn't apply to optimistic approach to scaling. Yet we've heard a lot about Arbitrum thinking about bringing and exploring how they can bring proofs to their technology as well, which again brings us to a point that maybe this proof is more required than some people thought initially.
And could we dive a little bit deeper and try to explain for those who are new in the field what data availability does, or what sequencer does, or what other parts? I guess there are also, in some cases, there are indexers and oracles that require required to be in the project. What is all of this for? Maybe there is also a line and like an analogy with the Web2 infrastructure. Like, there are certain infrastructure elements that evolved in Web3, hence they have a different name, but they still have some sort of lineage, to the old infrastructure.
Yeah, I mean, data availability, it's kind of the name itself is self-explanatory, right? So data availability came into play because initially, when you were processing everything on L1, all the data was stored. So the more data, block space is limited, right? It's like a ball. When you fill it, you can't put it in anymore. So then is the question, how much data we want to put in those blocks, right? So with what happened is, like with Optimistic, what you do is initially, I mean, you are posting all of the transaction data to L1, right? And this is fairly expensive because block space on L1 is expensive. So we had a few months ago that this was EIP 4844 that introduced a new way of passing data to the blockchain called blobs, right? Which decreased the cost, right? So I don't want to go deep into that. To be honest, I'm not the best person to explain the thing. But in essence, in practice, what it did is it enabled for less data, for more compressed data to be stored on blockchain, which decreased the cost, right? On ZK side, you are not putting the data on L1, right? So you need to store this data somewhere. And data availability node will enable you to put the data there, to be always able to access it, to check, right? But it doesn't need to be written on the L1, and hence eliminating the cost of posting that data and consuming that block space for just the purpose of storing the data. And effectively, you have an offline storage, like a database, where all the data is stored. and this is where you can access it at all times, right? You have one interesting thing is that with local data availability, which means that you have your own drives, right? And you store the data, you can keep it forever, right? Which means that if anything happens, you will be able to restore the state of the network. You will always have this data. But with third-party data availability and with blobs, the data stays available only for 14 days. Right? I think it's 14, maybe it's even 8, but it's a short period of time in essence, right? So after that, the data is gone, right? And this is data availability in optimistic side. It's only available for the time where you can challenge the state of the transactions, right? When you can submit this fraud proof. After this time passes, the state is considered finalized, right? And then there's no more need for this data, so you can forget about it, right? But this also means that you won't be able to access it if something happens and you want to check what was going on. And this is why I would say that this local data availability is very interesting, and ZK as a concept, zero knowledge networks here have this local data availability, and you can always access it and replay and bring back the network. And it even enables, if something happens, if the project would bail and the users will be stuck on the network, right? We could bring it back just to enable them to take out their funds or whatever they have there and then shut it down again, right? So this is what this data enables us to do, and this is why data availability in a sense is important.
Understood. Let's talk a little bit about other bits, because there are so many different tools connected to it. There is also like block explorers and bridges and faucets and indexers and oracles and all of these type of things. Not to go and look, we will have a separate episode, I think, on delving into all of these. But overall, that might be a little bit frightening for somebody who is approaching building a new Web3 project, whether simply within the Web3 field or coming from the Web2 to Web3. Do they need to be worried? Like how does it all work?
No, I would say definitely not. Don't be worried, right? So you don't want to do this on your own. That's one thing. I mean, we have teams developing this. Significant amount of resources being invested in this, right? And yet we see that only a few of them stay relevant for a prolonged period of time, right? We have a lot of alternative, like a few market cycles away, there were so-called Ethereum killers popping up. I mean, they're still popping up. Now, I don't know if anybody remembers which was the last one. So this is the thing, right? Why reinvent the wheel if we have a proven model, right? We have a proven model that works. We have a proven base settlement layer that works. Let's not develop a new one, right? And same goes with these L2 stacks. We have Optimism, we have Arbitrum. They are battle tested. They've been around for a few years, right? So naturally, several like projects initially were going there. ZK took a longer to develop, right? It's a more complex technology, and this is now getting picked up. And we are working hard, as we discussed quite thoroughly in this podcast today, that we want to bring the cost of infrastructure down so we can have the same rate of adoption as we had with Optimistic on ZK side as well, right? But when it comes to project, right, do you want to do all of this stuff on your own? I mean, it takes a lot of expertise to be able to manage that, right? You have all these bits and pieces that need to stay in place. When you really look at the infrastructure components, you need to understand how much processing units, how much memory, right? What is performing better, because you have different combinations of memory and processing unit. You have all of this hardware that has been developed through tens of years of research and development that offers so much variability. Good luck going through that, right? This is why this market of providers that help you set up your infrastructure emerged, right? And this is a good way to go, because you don't really have to bother with the infrastructure. You have the support, right? You just reach out. We take care of this stuff for you. And what we see with projects, most of them, they don't bother too much with what's going on. The most important thing for them is that it's available, it works, right? And if there's something that has not been expected, they have the option to come and say, hey, what is going on? Explain to us, is it something that we need to fix, or is it something that we need to fix on our end? We see a lot of clients think that something is going on with their chain, right? Their chain is relaxed, enjoying on the beach, more or less, right? Yet something is not working for them. And then they come and think, okay, something must be wrong with the chain. Something must be wrong with our access, like RPC or so on. No, it's not. I mean, something is wrong in your backend, for example, how you are passing information to the blockchain. So this just proves that you need to focus on building your own application, your own product, whatever you are doing, and don't worry so much, because you have your infrastructure team. You need to have a team that understands all the components, potentially understands very well the infrastructure and the hardware requirements and configurations, and then those people that will maintain, and that's quite expensive, right? You need a few engineers with the monthly salaries, and yeah, it's easier to just offload this part to someone who is expert and you can trust, and focus on building whatever you are building on top of that.
Let's cover CDK Erigon a little bit on the surface. We will have Igor on, of course, the core developer of CDK Erigon, and he will unfold it in the whole episode. But let's touch upon this. What happened? Why did it? What was the main purpose to release it, and how did it affect the costs, and how did it affect any other measurements of layer 2s, rollups, or any kind of nodes?
Let me put it this way. I mean, as you said, it's better. We will wait for Igor to really dive deep into that segment. But I'm a fan of fine dining, so I'll put an analogy in place here, right? So with Erigon, what happened is basically it's compared the old network. Let's say it's I don't know, your mom's and pop's restaurant, something nice, right? But not too fancy, not fine dining, right? Or whatever. But with Erigon, what we did, there's a lot of these things on the plate, a lot of things that might not be appropriate, tastes don't match. What we did with Erigon, what Igor and the team did, is they cleaned this all up, right? So you have a very nice plate. Every single component is thought through and is doing exactly what it should be doing, right? So we removed a lot of things that were on top that required additional servers, right? And now you have a very nice Michelin star fine dining plate that has only the things that are there to be and needed to be, which also, like, so it's optimized. Basically, we optimized, we cleaned it up, and now we can get more out of less infrastructure. Let's say before we had 8 servers, now we only have 5. Right? So this already decreased the cost by itself, right? And now, because this is optimized and each server has like, each server can, obviously this is where I have my expertise, and this is where Igor will start and explain, or possibly more, what happens. But we can get more out of the same machine. This is what in essence is. We need less machines, and we can get more out of the same machines with this new architecture. So it's a change of architecture. We have this normal thing. It's nice, it's okay, it works, right? And then you have this elevated experience on the infrastructure side. Again, how this will translate to users, they usually don't see. They will see the lower bill on their monthly invoice, right? That's one thing. And they will see more performance, right? So it's going to work faster. It's going to be more reliable. The TPS, or like, we don't want to talk too much about TPS because it's not so important, but the amount of transactions that you will process every day for the same buck is going to increase by significant margin, right? So this is something that happened with Erigon. It's a very beautiful piece of work. Let me put it this way.
And this advancement basically happened in the past couple of weeks. Like the release of CDK Erigon was in the past couple of weeks, right? So it already takes the costs down at least by, I don't know, 50%. And then you say there's advancements. So we can calculate the cost because it's getting significant improvements. And then, or whatever the number, I'm not here one to calculate this. But what I want to highlight is there is a significant advancement that just happened, and then before that, I know that Igor and the team contributed to 10x of the throughput on the overall technology, right? These advancements happen one after another, one after another, and again we're getting closer and closer and closer to this inflection point when it's just going to explode, and we know that's going to happen. Well, of course, we might be a little bit too passionate. We're not typical crypto lads, right? But we are on the cutting edge of technology, and we are here to support Igor and the team as well to do the best of their work. But I'm thinking now, I'm an entrepreneur and I'm listening to this podcast and I have a project in mind, either proof of concept, or I want to try to adopt existing project to this new technology, or I have a Web3 project and I'm thinking like, hey, there's constant advancement of the tech and I probably want to migrate my infrastructure to this instead because it will be faster, it will be cheaper, it will be all of these things. Where do I begin? How do I even do that?
Okay, elaborate a bit more. So what are you like as a founder?
I'm listening to us. I'm listening to this talk, right? And I hear, and for some reason I trust too, right? I don't know if there is a reason not to trust, but yeah, we're not having a token. We're not asking to invest money. We're not doing any of these things. We're really working on the cutting edge of technology. But and I hear these guys and I see like, okay, I want to explore this. I want to build a project with this technology. How do I? What is the first step to make here? Or what's the process overall? I know there that you can use Presto, you can roll up and everything, but what are overall process of building my project from the idea, from the conception? I get energy now, like, hey, they're talking about important things, and it seems like they have improved already, and they will improve even more. I want on board with them, and then from that point on up until the project is being basically released, what's the process?
Yeah, I mean, so obviously your starting point will depend on the amount of information you already have, so your experience level, right? But let's say you are familiar with the space, right? You know already what your idea is, and you are looking for, to set it up on your own rollup, whatever the tech stack, right? So, I mean, first, I would always say educate yourself a little bit. What are the different options, right? So you don't come into conversations, as you said, like you trust me, right? But we say in Web3, don't trust, verify, right? So you need to have a little bit of information into what you're getting into, so you don't get led into something that doesn't end up working for you, right? So you want to be educated enough to be able to make a decision on your own by collecting information from others. And then, I mean, from then on, I wouldn't say like, let's not do marketing, but you come to us, right? You can come to us, to some provider. We will talk to you about what you are aiming to build, right? What are the requirements you need, right? And what we see here is people and projects, founders have an idea of where they want to go. There's a lot of aspirations, right? Where they will end up, what kind of performance will they need, right? So I would say don't make a mistake by starting where you are not, right? Because if you come to us or to any roll-up as a service provider with an MVP that is not a production-ready thing, and you want to get to 1 million daily transactions, right? You're not there yet. There is a way to come to that. So don't try to gain or to onboard the infrastructure that will support you when you reach that point. Try to understand what is the best starting point for you, where you can test it. Do give yourself some time to start with the lower options so you don't burn money too fast. You understand how it works, because again, it's not about understanding how it works under the hood, but you want to get the feel for the car, right? Because this kind of car is going to drive a little bit different. Both are going to get you to the same place, right? But it's about your experience, right? What do you expect from this? You know the best what you want to build, hence you will know what kind of user experience you will best suit your needs, right? So focus on this. So how are you interacting, not just with the chain, but also with the team that you are working with, right? And what you are getting. Are you getting what you need, what you will need, or not, right? And based on these facts, then you can start making a decision which way you want to go. You will anyways get guidance. Like with us, what we pride ourselves on is that we provide this guidance, right? It's not just that you come to our platform, you do a few clicks, you deploy a chain, and then find your way around it, right? We are here, right? If you have questions, we support you, right? And we can guide you through these things. And then, yeah, it's about you understanding what you are doing, building and deploying MVPs, first smart contracts on chain, seeing how the thing performs. And then when you are confident enough that this is the solution for you, that's where you should decide to, okay, deploy the mainnet and actually roll it out in a production version, right? So you have few options before you come to mainnet. You can have a simple single server deployment, very cheap, right? A DevNet where you deploy your applications. You don't put users on that, but you are not in that stage where you are having users, right? So you can start with that. You can then roll out a full-fledged redundant infrastructure as a test net, where again, you have a second phase of testing. You put the same applications there, you bring the users in, you let everybody play around with fake testnet assets, right? So if something goes wrong, no harm, no foul, right? Yes, I mean, it's obviously not great that something goes wrong, but nevertheless, you don't have a real capital at risk. Once all of these things bring you to a certain level of confidence, that's the way to go. That's when you roll out the mainnet. And this is just from the perspective of understanding what your underlying infrastructure does. You obviously have your own roadmap on building your own, like on building the product side. So these are two separate things, right? This is just infrastructure, right? It's not part of your development roadmap, right? It should be in parallel with your development roadmap. And you have three steps. You have the developer testing, user testing, and production. These are the three steps you have on the way, right? So you can stretch this out as much as you want to fit your development and go-to-market strategy.
Yes, but even though its infrastructure is not in the roadmap, just not so long ago, it was in the roadmap for most of the projects and companies that have been building this, and it was extremely expensive, like 2 mil per year or something like this. We calculated, right? And then now you're taken down to significantly lower amounts, up to if you start with a DevNet, as you say, there will be like very, very like incomparable little small amounts.
Yeah.
And as you say, you can simply deploy a DevNet and start working with this already without any interruption automatically. And this is magic that happens. And this is again to highlight the closeness of inflection point, because the more of these automated scalable solutions will appear, there are very, very few of them right now, and we're on the cutting edge, really. But the more of them will appear, the closer the inflection point will be. But as I hear you, basically, as an entrepreneur, I need to take care of my project, front end, basically, marketing, everything else, and then infrastructure. I have wires from you. I plug it in there into my projects. First, DevNet, just to make sure that how it all works and all connected to the infrastructure. Then I unplug the DevNet, plug in the testnet, do the tests, and then unplug this and go live with the real thing that has higher cost, obviously, for ZK provers. But so it's not like I'm paying straight away big amounts for really high-end infrastructure during the development process. I go there, I test it, I validate, and if it's all validated and market validated, then we go with the full-blown solution. Is that how it looks?
Exactly. And we do see projects that are rushing a little bit. I mean, there's what is driving the timeline? That's the question, right? Is it the business decisions? Is it investors? Is it, I don't know, market, maybe the cycles? We have all of these variabilities, right? So, but usually what happens when people are rushed and they want to deploy, I'm just talking about infrastructure, right? When you want to deploy this mainnet as soon as possible, right? If you're really not ready, what will happen is what you described. You will be burning cash because the infrastructure will be running, right? But you won't have any transactions there, right? Nothing's gonna happen over there. So you're just wasting money, right? And this is why it's really important to have your roadmaps and timelines nailed down, not for the DevNet. Like DevNet is really the thing you need to start if you are early on. You can play around. It's extremely cheap. We're talking $1,000, right? Anybody can afford $12,000 per year, right? But when it comes to testnet is not that. I mean, compared to mainnet, infrastructure wise, if you have a prover on testnet, so you can test technology like UgLayer, for example, right? Then the infrastructure cost is the same, right? On the starting point. The only difference is that on testnet you're playing with monopoly money, and on mainnet you're playing with the real stuff, right? So this is the difference between the two, but the infrastructure wise is the same thing, right? Because you want to get the experience you will be having on mainnet, you want to have it on testnet, right? On devnet, not so much, because that's for internal stuff. That's for your devs to understand how to connect, how to get data from, how to post data to, and so on, right? But when it comes to user testing, yeah, the things should be the same. And then obviously, don't start with something that you will need in a year. Start with what you need now, because it's very easy to ramp up, and it's not so easy to ramp down once you burn the 100K unnecessarily, right? That money you won't get back, right? So that's something that you would I would put across as the good approach to this, to implementing this kind of infrastructure.
Thanks. This is good. So I know that you give basically free, no commitment consultations on these topics. And how do people reach you? What's the best way to talk to you?
Well, we are very approachable people, let's put it this way, right? So in Web3, there is not much formality, and this is why I like this space so much. I mean, Telegram is obviously where we are accessible the most. Email, sure, but it's probably going to get buried and no response will come out of it, right? Nevertheless, it's no harm in trying. But yeah, Telegram is the best way to be reaching. Twitter, not so much. I mean, honestly, yeah, Twitter for DMs, I don't think it's really there. You have too much of these bots. Again, I personally don't check DMs at all on Twitter, but on Telegram I will actually see it very soon. And then yeah, don't be mad if I leave the scene sign, and maybe because I will respond. It just might take a few hours or so to come back.
Thanks. This is good. We will post your Telegram account to the description of this video. And for everybody else listening, I would highly encourage you to put in the comments below whatever topics we covered today that you want to be unfolded. Because as the podcast begins, we cover it with, or maybe if you listen to it later, we'll still pick it up. We're beginning with the surface of the projects, with the surface of the Web3 technology, with the surface of what's happening exactly now. And then for the topics that you are interested in, we'll bring in more focused specialists who are within this specific area working right now, and they will unfold for you in the more technical terms, whatever you would like to understand. But for now, I just have to thank Peter for this fantastic conversation. I think it was very energetic, very fast, and at the same time, very, very valuable. So many different insights. Yeah, I hope that will bring quite a bit of context for everybody else who exploring the topic.
Yeah, I certainly hope so as well. Thanks so much, Dennis, for hosting me. I mean, it was a pleasure to spend Friday afternoon with you. Way more relaxed than usual Friday working. So enjoyed it so much. Thanks so much, man.
Thank you. Have a good one.
Bye-bye.